Quad66, you're back for part 2. So let's dive into the black. So I've got 3 logs. So I've got the QX7. All 3 of these are going to be with the RC smoothing at 30. And then on the first 2, so the QX7, this feed-forward smoothing is at 66. And I've got the jumper T-Lite, again with the feed-forward smoothing at 66. And then I've got one more on the T-Lite with the feed-forward smoothing bumped up to 75. In terms of what we're looking at, so the issue with the jitter is that when we're using feed forward is kind of like a D term, sort of looks at the rate of change and tries to, from the rate of change, tries to guess where your signal is going to go. And that's why when you have jitter, feed forward is where that amplification is going to occur. On this one, so this feed forward smoothing is pretty heavy, it's 66. But we're also, our sampling rate is 500 hertz, so we have some room to play with, and so you can use this pretty heavy feed-forward smoothing at 66, and you still get quick response. So in orange here, this is my feed-forward trace. So you can see how much quicker the feed-forward comes up than the P-term. So the P-term is waiting for error to occur. So my set point is here. This is my sticks, what I'm actually telling the quad to do. This is how feed forward is interpreting that, and so you can see how feed forward jumps. It's actually jumping before the set point. It looks that way. It's not really doing that, but it basically jumps fast, and that's why this gyro trace can follow the set point so well. So in purple, I'm highlighting that gyro trace, and you can see how there's just very minimal gap, and it's this gap here between our set point and a feed forward trace. That's what P is responding to. And you can see how much of a delay there is from feed forward to the P. So if we were flying on P term, we'd be waiting all the way over here to go ahead and push the quad, and subsequently, up here we'd be overshooting because we'd be coming in late, pushing too hard, and then sending the trace up over the set point, or the gyro up over the actual set point, which is not what we want. And so that's why the feed forward is so nice, because it comes in early, pushes this up, and now you're staying relatively parallel. And when your gyro stays parallel to your set point, that's how you can keep it from, or minimize, the overshootings, because you're never coming in at too steep of an angle. So that looks great. That's great. We've got now a super responsive quad, and it's flying really well. And so this is on the QX7 with the Hall sensor gimbals. Now, when we go to the T-Lite with the same exact settings, you can see now, look at our feed forward trace. It's got like the sawtoothness, it's jagged. And so that's the jitter it's picking up. So what it's doing is it's looking at the change, the change in the set point, and it's seeing the jitter from the gimbal, and it's amplifying that, it's magnifying that. And that's what it has to do to be able to jump early. Now you can see on this trace still the quad is flying beautifully, and so it's not really an issue of the quad responsiveness. We still have really good, so look at our gyro, stays right on that set point really well, so it's still handling really well. But the issue is that the feed forward, actually in this case, if you look at it, look how these spikes are actually bigger than our D term. So this is actually, feed forward trace has actually putting more noise into our motors than our D term, which is, it's kind of a lot, it's kind of a problem. To give you another view of that, we can go ahead and plot these and visualize it. And so here's that feed forward noise on the QX7. So this looks pretty tolerable, pretty good. And now compare that to the jumper T-Lite. And so these are on the same settings, and you can see there's this whole pile of noise, fairly low frequency noise, and this is all just going into the motors. Now the motors can't necessarily respond quite this fast, but this is going to be motor heat. Also just more electrical system noise in general. So comparing these two, QX7, jumper T-Lite, pretty big difference. So then the next question is, okay, well, we have some room to push up the feed forward smoothing, and we can go up to 75. So this is the max that you can push it to on in Betaflight 4.3, and it works. The feed forward jitter is still here, but it's less. And you can see on this trace at least, we're still getting what looks like good tracking, set point tracking. So here's our gyro, still jumping with a set point pretty well, looks pretty good. And when we go ahead and plot out the noise, basically it's kind of in between. So not quite as good as the QX7 at 66. The jumper T-Lite with the feed-forward smoothing at 75 is actually not awful looking to me. I mean, these are all kind of like relative and subjective terms, you know, in terms of looking at this plot and how much this is really generating motor noise and how much efficiency are you losing because of this, you know, versus that. It's kind of debatable. I think this difference is probably enough to maybe get a little bit concerned about. So then, okay then, so what's the problem with this? Why not just use our filtering? Well, although we don't really see it here, I'll show you where we do see it. So where we do see the issue is when we have our fast like back and forth twitch movements. So when you're cutting the stick side to side, like you're reacting quickly, and here's these over here. So let's go ahead and compare now our T-Lite so that we take the we're taking the gimbals out of the equation. We're just going to look at the difference in using that extra feed forward smoothing and seeing what it does to our responsiveness. And so let's find this spot where I've got these nice back and forth. Here we go. So here's a nice set of them. So here on feed forward smoothing of 66, you can see all that feed forward jitter, but the quad is flowing beautifully. So here's a set point, here's a gyro. You can see how the set point and gyro, I mean, the gyro is just, it's right on the set point. This looks fantastic. Now compare this to 75. So here's our set point in green, here's our gyro in purple. And what you can see is when you're changing kind of direction, so this is like telling the quad to move and then you're going back and forth, you can, so watch the little quad move, so you can see what we're doing with these little moves here, okay? What you're seeing here is this overshoot, and that's because when we're smoothing the feed forward term, we're delaying it. So what ends up happening is that the feed forward is coming in late, hanging around too long, creating our overshoot, and then coming back late. So instead of like pulling this back when you need to, it comes in late, and it's this delay, it's this phase delay that takes the peak away from where it should be and moves it too far. And you can see the P term coming in trying to fix that up a little bit, but it's too slow of a term to really keep that in check. And it's not maybe, you know, 100%. I don't always see it, but I do see it creeping in enough to where I think this is a true difference from 75 to the 66. You know, to me this stays on 66. To my eyes, this stays on the gyro better. Now, is that meaningful? I don't know, hard to say. But I think if there is a place that this could become meaningful, it is sort of in these scenarios where this is, for example, you're coming in to the line just a little bit wrong, something surprises you, trying to do a quick correction. Now, when you're trying to do these real quick corrections, you have a tendency, like, in terms of what you're doing with the stick motion, to be like a little over aggressive with the stick. And so then you add on top of that this extra little overshoot, and maybe that does push it over to where you kind of have this, you know, kind of like you overcorrect back and forth because your quad is moving more than you actually intended to. So, you know, is this a deal breaker on a T-Lite? I don't think so. I think out of a $75 remote, it's really not that bad. You know, I think it looks pretty decent, but we're giving up some of what we gained from going to 500 hertz. So this level of overshoot, it's not as bad as what I was used to seeing when I was flying on, you know, the FR Sky, XSRS. But, you know, to me, it's definitely not quite as good as, you know, what we can get out of the QX7 without the excess noise. So let's go down to, there's a, I mean, that's just beautiful out of the QX7. So here's our gyro. Gyro is just right on the set point. I mean, they're like indistinguishable. Let's see if we can find those like back and forth still. These, by the way, these are split S's. That's what these are. And then maybe a touch, a little hint of overshoot there. But I think that looks pretty fantastic without the noise. That looks pretty good. I think it's there. So, I mean, if you're just buying a remote and you're starting from scratch, and travel isn't your primary concern, and really just all-out performance is your primary concern, then I think like QX7 with Hall sensor gimbals is superior to the Jumper T-Lite. All other things not taken into account. I mean, I like the way the gimbals feel on the QX7 better than the T-Lite, so that's another point, but you know, if you just have one radio and you're getting used to it, maybe that becomes sort of a mood issue to you. All right, so let's leave you with one last look at the noise, because I think that's the main story that we're trying to say here. So QX7, Hall sensor gimbal, T-Lite, jumper jitter right there. All right, till next time, cheers.